Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, it is a pleasure for me to present our project under the title Performance of Greenhouse Effect Hybrid Dry Dryer in Drying Cloves. Let me to introduce myself. My name is Rita Khotir. I am a lecturer at Department of Agricultural Engineering, Faculty of Agriculture, Universitas Syekh Kuala, and it is involved in my team Dr. Leopold Oscar Nelwan from Bogor Agricultural University and Professor Dr. Made Sucipta from Universitas Udayana. Ladies and gentlemen, we already know that the common way to dry agricultural product applied by our people is the oldest method, that is sun drying method. So we want to transform this open sun drying method to the use of the solar dryer. So the objective of our study is to evaluate the performance of greenhouse effect hybrid dry dryer in drying cloves. And then we want to improve the quality of cloves, of course, and also increasing the capacity of cloves in a batch of drying processing, and at the end we expect to improve the economic of the people. And here we can see the solar dryer that we had evaluated in this study. It is a type of greenhouse effect solar dryer because it is covered by a transparent cover, so then the solar irradiance is trapped inside the drying chamber, so then we can gain the heat. And it is also a type of hybrid solar dryer because it have a biomass stove, so we can burn the biomass here to have additional heating resources. And this dryer has 10 trays, 10 layers of trays, and it has also two air inlet and one air outlet. The first air inlet is located here above absorber area by natural, and the second air inlet is located here, and the air is blown by two axial fans at 1400 rpm, and we had run two experiments respectively with the capacity of 72 kilograms and 142 kilograms of cloves. As a result from our experiment, you can see here that on the first picture, we did the first experiment by drying 72 kilograms of cloves in 3 days, whereas in the second experiment, we need the time about 6 days. We can see that in the first experiment, we have the beta solar irradiation, and you see that then the total of charcoal to be used is lower, but on the second experiment we have a bad weather condition, so then we have to improve the use of biomass or charcoal. And then if we compare the drying temperature among the layers, we can see that we have a good uniform temperature. However, the temperature on the first experiment is better than or higher than the temperature on the second experiment. And then altogether, if we compare the temperature in the drying chamber compared to the temperature in the environment, so we can see that the temperature inside the drying chamber of solar dryer is much higher than the temperature in its environment. And for the humidity, on the first experiment, when the weather is good, we can see that the humidity inside the drying chamber we can reach below 50%. However, on bad weather condition, it is very hard to have low humidity inside the drying chamber. And for the quality of cloth, we can see here that by using the dryer, we can reduce the moisture of cloth about 8 to 10%, and it's much lower than the moisture that we can result from the open sun drying method. And also the contamination is much lower compared to the open sun drying method. However, the oil content and the color of the two method has no changes. And for the performance, you can see here that in the first experiment we have the good solar irradiation, so then the solar energy support the system is about 34%. While on the second experiment, we can see that we have a bad weather, then we decrease the solar irradiation to 15%. And then by this, we have to increase the use of biomass energy up to 75%. So, respectively, the thermal efficiency of the first experiment is 15%, while on the second experiment is 14%, but the drying efficiency was equal at 17%. And for energy specific, we can see that the energy specific use at the first experiment is lower than the energy specific use at the second experiment. So we can see here that the good weather has effect to lower the energy specific use for the drying, because you know that the solar energy is always free for us. So then we can conclude that the dryer performance is better than the open sun drying method. It means that the dryer can improve the product quality, and also the dryer can increase the capacity of drying. The application of the dryer would bring the benefit for the farmers economically. However, some improvements are still needed for the dryer designs, because we have the problem that at bad weather condition it is very hard for us to reduce the humidity inside the drying chamber. So if we can reduce the humidity inside the drying chamber at this bad weather condition, we can improve the drying efficiency. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.